All right, so let's talk now more specifically about the different processes and the different types of sedimentary rocks. We said that sedimentary rocks are rocks that are composed of sediment that, from another rock that was weathered, and then that sediment was transported and lithified. Okay, we have two subcategories of sedimentary rocks. We have chemical sedimentary rocks, and we have detrital sedimentary rocks. Now, the difference in these is solely based on the type of weathering. When I say chemical sedimentary rocks, that means that the original rock was weathered by chemical means. So guys, what's an example of a chemical process that breaks down a substance? What do you do if you put sugar in a drink? What happens to the sugar? It dissolves. That's exactly right. And that's that physical process. What happens if you put salt in a drink, in water? It dissolves. It's the same thing, right? So if you guys remember, from last week, we talked about how halite was the mineral that we use for salt. So if halite is then exposed to water, it will dissolve, then it will be transported, and when it sits somewhere, it will come out of solution and become a sedimentary rock called rock salt. It's a hard science, isn't it? Okay, so we have chemical rocks. We also have detrital rocks. Detrital rocks refer to rocks that have been weathered by physical weathering means. So the best example of physical weathering, can you guys come up with any examples? Go, do you know of?
Like rain and stuff.
Like rain and stuff, right. How do you break rocks? Rain is probably the most efficient way to do it. You also have frost wedging, any type of weathering process that will physically break down a rock. That sediment is then transported a great distance before it is laid down in a bed, deposition, and then lithified through pressure. Okay, so what is an example of a detrital rock? A great example of a detrital rock is sandstone. We have a great example of sandstone in your kit. If I could get the camera to come in and zoom in, please. Now, this sandstone, as we said, is a collection of minerals, just like every rock is. And the primary mineral in this is what? Sandstone.
Lime.
What is it?
Limestone?
Limestone is incorrect. Calcite is incorrect. How are we going to find out, right? So Lucy doesn't know it off the top of her head, which is fine. I've done this for years and years and years, and I happen to know it, but she's only done this for like 8 years. So she, probably would have expected her to know that at all. All right, how are we going to find out what mineral is in sandstone?
We will use these tests.
We will use these tests. That's exactly right. A very important point here is that when minerals combine to make rocks, they do not lose their physical characteristics. So what test are we going to use to test the identity of this mineral?
I don't know. Where do you want to start? What do you want to start?
So Lucy said calcite. Do you remember the physical smoking gun property for calcite?
Is it the acid?
Acid. So let's test it with acid. Do we see a fizz?
Nope.
No, we don't. Therefore, we know it is what? It is not
Calcite.
calcite. What's the next test we're going to do?
Can scratch it.
Scratch with glass. And that tests for what mineral? Lucy?
Quartz.
Quartz is exactly right. Does it leave a scratch? Yes, it does. So now we know that the primary mineral in sandstone is quartz. We're going to go through several of these other rocks now and decide what primary mineral is in each of them.